Dear students, welcome to our physics channel. In this video, we are discussing about electric field due to electric dipole on axial line. Now, we have to consider electric dipole. Andre, it's nothing but electric dipole having a equal and opposite charges, separated by some small distance, that is 2a. Here, in between of these two charges, we are considering the center of the dipole, that is O point. Now, we have to extend the axial line. Otherwise, we have to put the axial line. It's nothing but straight line. Okay, on the axial line, we are considering a point P. You people already know in the representation of the electric field. Here plus Q is exerting the electric field. Otherwise plus Q is radially outwards. It will creates the positive charge, creates the electric field radially outwards, that is E plus Q. Here minus Q charge, otherwise negative charge, it creates the electric field radially inward, that is E minus Q. And here direction of the dipole, that is considering from the negative to positive. Always electric dipole having the direction from negative charges to positive charges, and this is considering as P. Here we are considering distance from P to O, that is R. Now I will start to write the derivation. Here electric field E plus Q. Now we have to calculate the net electric field. Here we have to calculate otherwise we should calculate the net electric field. First I am considering a positive electric field. Andre, it's nothing but this electric field is creating from the positive charges. So electric field E plus Q due to the positive charge. So equation is E plus Q is equals to 1 divided by 4 pi epsilon naught Q divided by, here we have to calculate the distance between the P and plus Q charge. So we have to minus, this is considering as a distance, this one is a distance. Now we have to consider the distance from P to positive charge. So I will consider R minus A. What we have to take? R minus A. R minus A whole square. And now here P cap is the unit vector. Next, electric field. Now electric field created from the negative charge due to the electric field creating from the negative charge. So E minus Q is equals to 1 divided by 4 pi epsilon naught Q divided by, andre now we have to consider distance from P to negative charge. Andre we have to add the R plus A. Now we have to consider R plus A distance. Here we people already learned in electrostatics, Coulomb's electrostatics. Here there 1 divided by R square, that is the inverse square law. And so here denominator we should consider in square, so R plus A whole square. Now minus P cap, andre see here this negative charge electric field and dipole, these two are opposite, so I will write unit vector in negative sign. Now we have to add the, otherwise now we have to calculate the total electric field, andre net electric field. So E net is equals to E plus Q plus E minus Q. E plus Q ಅಂದರೆ 1 divided by 4 pi epsilon naught Q divided by R minus A square. ಇಲ್ಲಿ minus is there na. Now I will consider in between here. So 1 divided by 4 pi epsilon naught Q divided by R plus A whole square P cap. Here plus is there. I return minus here only. Okay na? Now I will take common 1 by 4 pi epsilon naught into Q. Remaining term is 1 divided by R minus A whole square P cap minus 1 divided by R plus A whole square. See here P cap I will write outside of the square bracket, because here also P cap, here also P cap. I return this P cap outwards of the bracket. Next 1 divided by 4 pi epsilon naught Q. R plus A square into 1 ಅಂದರೆ R plus A square minus R minus A square into 1 ಅಂದರೆ R minus A whole square divided by denominator we should consider in LCM. Okay, R minus A whole square, R plus A whole square. I will write total whole square, R minus A, R plus A whole square. Here P cap is as it is same. Next 1 divided by 4 pi epsilon naught Q into ಇಲ್ಲಿ R plus A whole square, R minus A square whole square. Here I will apply identity, A plus B whole square. This one is A minus B whole square. These two steps are identity related. A square plus B square plus 2AB. Next A square plus B square minus 2AB. So here A is R, B is A. And now we have to apply the identity. R square plus A square plus 2AR minus R square plus A square minus 2AR. Here P cap is as it is same. See here A minus B, A plus B, and A minus B, A plus B is equals to A square minus B square. Okay na? See here A square ಅಂದರೆ R square minus A square, here whole square. Next 1 divided by 4 pi epsilon naught Q into ಇಲ್ಲಿ R square plus A square plus 2AR. This bracket I return as it is same. Now minus into R square minus R square minus into plus minus A square minus into minus plus 4AR. Sorry, 2AR divided by R square minus A square whole square. Here P cap as it is same. Plus R square minus R square cancel, plus A square minus A square cancel. Now 1 divided by 4 pi epsilon naught Q into 2AR plus 2AR ಅಂದರೆ it's nothing but 4AR divided by R square minus A square whole square P cap as it is same. Now net electric field is equals to 4 pi epsilon naught Q into 2AR. We have to write separately, that is 2A into 2R divided by R square minus A square into whole square P cap. Here net electric field is equals to 1 divided by 4 pi epsilon naught. Here 2AQ is the equation of dipole. So P equals to 2AQ. So I will write 2RP ಅಥವಾ 2PR divided by R square minus A square whole square. Here P as it is same. Here P is there. P and P cap is equals to P. So E net is equals to 1 divided by 4 pi epsilon naught 2RP divided by R square minus A square whole square. This is the final equation of the electric field due to the electric dipole on axial line.